Okay, so today we're going to be on Unit 8A.4.
You're recording.
Yeah. 8A.4. Okay, and
home on the range.
we only have 2 more objectives. Okay, and everything we're going to do today and tomorrow is involving solving. Okay, so we're going to solve exponential equations. Solve exponential equations. We're also going to be solving exponential equations tomorrow, but today we're going to deal with them, or all of the equations are going to have where the variable, solve exponential equations where the variable is the exponent. Okay, so we're solving exponential equations where the variable is the exponent. So, what you need to know is if we have the x in the air, okay, if the x is in the air, what we want to do, the procedure we're going to follow, is we need to get same bases. Okay, we want to get the bases to be the same, and then drop them. Okay, if x is in the air, you want to get the bases to be the same and then drop the bases. Alright, so something like this. For number 1, if we have 3 to the 3x equals 3 to the x plus 8. 3 to the 3x equals 3 to the x plus 8. There's a property in math that says if you have 2 of the same bases, you can get rid of them. Okay, so the base here is what's on the ground. The exponent is what's in the air. That's what we call an exponent. So since the bases are exactly the same, what you can do for this is you can get rid of the bases. Okay, we can literally just cancel these out, get rid of them. And you can take whatever's left in the air, the exponents, and set them equal to one another. So 3x equals x plus 8. Then we're just solving. We're solving for x here. So what would you do to solve for x? Subtract the x from both sides. You subtract the x, so it's going to give you 2x equals 8. And then divide both sides by 2. And we should get an answer of x equals 4. That's it.
Oh, yay.
Not too bad, right?
It gets hard.
It's not too bad. Okay, let's try another one. For number 2, same type of idea. 5 to the x plus 1 equals 25 to the x minus 6. 5 to the x plus 1 equals 25 to the x minus 6. So, what we have to do first is, remember, if I said the x is in the air, we need to get the same base. So, if you look at these bases, 5 and 25, could you get them both to be the same base?
Yeah.
What's my goal base?
25.
Can you, okay, let's think about this. We can't change 5 to be a base 25.
Oh.
But I could change 25 to be a base 5. So you're always going to want to go,
To the lower one?
well, I'm going to show you on another one in just a second. So you want to go to the simpler one. So here, we're just going to rewrite 5 to the x plus 1 equals 5 to what power equals 25? 5 squared to the x minus 6. Now, what happens when you have power to power? Do they add or do they multiply?
Multiply.
They multiply. So 5 to the x plus 1 equals 5 to the, distribute this 2 to the 2x minus 12. Now that we have the same base, we can drop the bases and solve for the exponents. So x plus 1 equals 2x minus 12. If I want to solve for x, what do I have to do?
Subtract 1.
Start by subtracting an x. We're going to move it to the other side. Doesn't matter which side you move things to. Okay, so we get 1 equals x minus 12. To get rid of this 12, add 12 to both sides. We're going to add 12. And that'll give us 13 equals x. Does it matter that I solved and it's on the left side?
No.
Doesn't matter. Okay, so 13 is equal to x.
Isn't that the same as x
Oh,
equals 13 though?
Yes, 13 equals x, and x equals 13 are the same thing. Yes. So that's why I said it doesn't matter which side it was on. Okay, let's try another one. For number 3, we only have 4 examples today, so you guys need to make sure and pay attention because I'm not doing a ton of examples on the same thing. Okay, 4 to the 2x equals 1/2 to the 1 minus 2x. 4 to the 2x equals 1/2 to the 1 minus 2x. So before you look at the exponents, I want you to look at the 4 and the 1/2. What base do they both have in common? Can I change? Okay, let's think about this. Can I change a 4 to be a base 1/2?
No.
Can I change a 1/2 to be a base 4?
Yeah.
Technically, we could. Okay, but here, you're going to have to change both bases. So on like number 1, you didn't have to change either base. Okay? On number 1, we already had the same base. So you could leave them alone. On number 2, you had to change one base. Okay? We changed one base to match the other. Change one base to match the other. And that was fine. We figured out how to make them match. On number 3, we have to change both bases. So if I want to change both bases, what would 4 and 1/2, what base would they have in common?
2.
Base 2, right. So you have to be really good at your exponents here. You need to know, like, you know, 2s and 3s and that kind of thing. You don't have to know, like, up to a ton of numbers, but your basic, like, exponents you really do need to know. So 2 to the what power equals 4. 2 squared equals 4. Take it to the 2x power. Equals what power? 2 to the what power equals 1/2? 2 to what power equals 1/2?
-1.
-1. So 2 to the -1 raised to the 1 minus 2x. Now when you have power to power, what do I do with them? Add or multiply? Multiply them. So 2 to the 4x equals 2 to the, distribute this -1, so -1 plus 2x. Now that I have the same base, you can drop the base and set the parts equal, or excuse me, set the exponents equals for each other. So 4x equals -1 plus 2x. Subtract the 2x, and now we're just back to the basic Algebra 1 solving. So 2x equals -1. Divide both sides by 2, and we get an x value of x equals -1/2. Questions on how I did that? Yeah.
How do I get the second step, second layer?
Mm-hmm.
There's 2 and then the negative on the inside.
So then you, great. Do you understand that 2 to the -1 is equal to 1/2? Remember, fractions are made from negative exponents. Okay, last one. Last one I want you to worry about here is for number 4. Okay, number 4. Let's write 3 to the 2x plus 1 equals 3 root 3. 3 to the 2x plus 1 equals 3 root 3.
They're all 3. Just cancel them all out.
You cannot just cancel them all out. Do I have the same base right now?
Yes.
No.
Not yet. Okay, I can't just cancel out the bases. You can't just say 3 and that's gone. Doesn't work that way. Okay? I want you to basically like split this. Okay? This would be equal to the 3 to the what power equals 3.
1.
3 to the first multiplied by 3 to the what power equals root 3. 3 to what power equals root 3.
3.
Put it in power handle.
1.
3 to the first?
2 to 2.
Let's think about this. What's the power here? 3 to the power of 1, handle of 2. So 3 to the what power equals root 3? 1/2.
1.
So if we rewrite things like that, okay, 3 to the 2x plus 1. Now, if I have 3's next to each other, how do I get them? What do you do with the exponents, right? Add them or multiply them?
Add them.
Add them. So 3 to the 2x plus 1 equals 3 to the, if I'm going to keep this in fractions, what's 1.5 written as a fraction?
1 and 1/2.
Okay, do I like to work with
3 over 2.
3 over 2, right? I'm going to leave them in improper fractions as opposed to mixed numbers. Mixed numbers are a little bit more difficult. Then drop your bases. Make it so that 2x plus 1 equals 3 halves. And how do I solve for x? What's the first thing that we don't like in this equation? We don't like the fraction. How do I eliminate the fraction?
Just take it out.
You can't just take it out.
Multiply.
Multiply everything by what?
I know.
By a
You
2.
just erased
Right. Multiply everything by a 2. So distribute your 2. We got 4x plus 2 equals 3. And then you can solve. So subtract 2 from both sides. We got 4x equals 1. Divide both sides by 4. And you should get an x value of x equal to 1/4.
It's pretty easy to take out. You just hire it.
Questions? Not too bad? Okay. You are going to be doing worksheet 4 for this objective, and you're doing numbers 1 through 21. Okay, worksheet 4, number 1 through 21.